A changing landscape. For decades, manufacturing has been undergoing a significant transformation driven by advancements in robotics. Initially, robots were largely confined to performing repetitive and hazardous tasks on assembly lines. Think welding car bodies or applying paint with unwavering precision. These early robotic systems, often referred to as remote-controlled machines initially, lacked the sophistication of today's models, but proved invaluable for increasing production speed and reducing errors. Now, however, modern industrial robots are far more versatile. They utilize complex sensors, computer vision, and artificial intelligence to handle intricate assembly processes, inspect components for defects, and even collaborate directly with human workers in shared workspaces, a concept known as cobotics. This evolution has moved beyond simple automation towards adaptable, intelligent systems capable of handling diverse product lines and customized orders. The integration of robotics into manufacturing facilities offers numerous benefits. Beyond the initial gains in speed and accuracy, companies experience reduced operational costs due to lower labor expenses and minimized waste. Robots can operate continuously without fatigue or breaks, leading to higher throughput and improved efficiency. Furthermore, they enhance workplace safety by taking on physically demanding or dangerous jobs, protecting human employees from potential injuries. This increased productivity allows manufacturers to remain competitive in a global market where speed and cost-effectiveness are paramount. The ability to quickly reconfigure robotic systems also facilitates the production of smaller batches and more personalized products, catering to evolving consumer demands. However, this technological shift isn't without its challenges, particularly concerning employment. While robotics undeniably boosts overall productivity, it has led to displacement in certain manufacturing roles. Traditionally, repetitive manual labor positions are most vulnerable to automation. This doesn't necessarily equate to a net loss of jobs, though. The rise of robotics also creates new opportunities, specifically in areas like robot programming, maintenance, engineering, and data analysis. The key lies in workforce adaptation. Retraining programs and educational initiatives are crucial to equip workers with the skills needed for these emerging roles. A significant vocabulary shift is occurring within manufacturing as well, moving from a focus on manual dexterity towards expertise in technology and problem-solving. Looking ahead, several future trends promise even more profound changes in robotic manufacturing. We can expect increased adoption of artificial intelligence, AI, powered robots capable of learning and adapting to unforeseen circumstances without human intervention. Digital twins, virtual replicas of physical factories, will allow for simulation and optimization of production processes before implementation, minimizing risks and maximizing efficiency. Collaborative robots, cobots, are predicted to become even more prevalent, working seamlessly alongside humans in increasingly complex tasks. Furthermore, advancements in sensor technology and machine learning will enable robots to perform more delicate and nuanced operations, expanding their applicability across a wider range of industries. Ultimately, the future of manufacturing is inextricably linked with robotics. The successful integration of these technologies requires proactive investment in education and training, alongside a willingness to embrace change. While concerns about job displacement are valid, focusing on upskilling the workforce and fostering innovation will be essential to harness the full potential of robotic automation. The goal isn't simply replacing human workers, but rather augmenting their capabilities, creating safer, more efficient, and ultimately more resilient manufacturing ecosystems capable of meeting the demands of a rapidly evolving world. Vocabulary list. Questions. Choose T for true or F for false. 1. Early industrial robots were primarily used for complex, highly adaptable tasks requiring significant AI. 2. The term cobotics refers to the collaboration between humans and robots in a shared workspace. 3. A primary disadvantage of using robots in manufacturing is their inability to operate continuously without breaks. 4. Reduced operational costs are not considered a benefit of integrating robotics into manufacturing facilities. 5. The integration of robotics has only impacted traditionally manual labor positions, leaving skilled jobs unaffected. 6. Retraining programs and educational initiatives are unimportant in mitigating the negative impacts of job displacement caused by automation. 7. Digital twins are physical robots designed to mimic human movements. 8. The future of robotic manufacturing is expected to see a decrease in the use of AI-powered robots. 9. Advancements in sensor technology will likely limit the types of operations robots can perform, focusing on simpler tasks. 10. The passage suggests that the ultimate goal of robotics in manufacturing is to completely replace human workers with automated systems.